Hello everyone, welcome back to the channel. My name is Teacher Samuel, and today we have a very exciting application of half model question. Now, this is a particularly difficult question in NMOS past year exam. But not to worry, I will take you through this question step by step. So without further ado, let's take a look. The figure is a square. Given that triangle ECF is 48 centimeters squared, find the area of triangle BMC. Now, students, any ideas how can we solve this question? First, we can start with a simpler question. Can we calculate triangle BMC directly? Unfortunately, we don't have enough information in this question, so the answer is no. But not to worry. If we cannot calculate the area of this triangle directly, then what else can we do? That's right. We can try and find a relationship with the given information. Now, to do that, first I need to explain a very simple concept to you. So let's clear the screen to do that. Now, in this simple figure, which is a rectangle, what is the relationship between the area that is shaded, so this shaded area, and the unshaded area, this part over here? What is the relationship? That's right, they are the same area. And if that is the case, what is the relationship between the shaded area and the whole rectangle? What is the relationship there? That's right, the shaded area is 1/2 of the whole figure. Now let's try an even more difficult example. In this rectangle, what is the relationship between this shaded area and the two unshaded areas? If you said that they are the same, then you are absolutely correct. Now, how do you know that the shaded area and the unshaded areas are the same? We can split this figure into two parts with a vertical line like this and consider both parts separately. So in the left part, it is very clear that the shaded area is the same as the unshaded area. And likewise in the right part, the shaded area is the same as the unshaded area. Therefore, in the whole figure, the shaded area is the same as the unshaded areas. And so, what then is the relationship between the shaded area and the whole rectangle? What is the relationship? Yes, that's right. It is also 1/2 of the whole figure. Now, let's see this example. We have here not just one, but 3 triangles. Now, in this figure, what is the relationship between the shaded area, so the area of these 3 triangles, and the area of the whole figure? What are the relationships? Also 1/2 of the whole figure. And how can we prove that? Similarly, we can split this figure into different parts, but this time into many different parts with many vertical lines. And we can consider each part individually. So for example, let's take a look at this left part over here. Now, what is the relationship between the shaded area and the whole leftmost part? What is the relationship? Very clearly, the shaded area is 1/2 of the whole part. And if we check every other part, that is the case. The shaded area is 1/2 of the part. Therefore, in the whole figure, what is the relationship between the shaded area and the whole figure? It is also 1/2. Now, in these 3 examples, we see that the shaded area is 1/2 of the whole figure. Therefore, we call these examples of the half model. Now, this is a very important concept in geometry, and it is also very important for our question at hand. So, keep this in mind and think about it while we look back at our question. So, here is the information in the question. We have the figure in the question, which is a square, and the important piece of information that triangle ECF is 48 centimeters squared. And remember, we are trying to find the area of triangle BMC. Now, where were we at this question? If you remember, we are trying to find a relationship with the given information. Now, based on looking at this figure and what we have already learned, Can you explore any relationship over here? We notice that this square can be split into a top part and a bottom part. So let's consider them separately. We can first consider the top part, which I have marked in red. Now, what relationship can we find in just this top part? Look at these two triangles which I have marked in blue over here. What is the relationship of the areas of those two triangles and the area of the whole top part? That's right, it's a half model. So the area is 1/2 of the whole top part. So we can now consider the bottom part, which I have marked in red over here. Now in this bottom part, what relationship can you observe? We can take a look at this big triangle marked in blue. Now, what is the relationship of the area of this big triangle and the whole bottom part? Also a half model. So also the area of the blue triangle is 1/2 of the whole bottom part. And therefore, what is the relationship between the areas of all the blue triangles and the whole square? 1/2 the area of the whole square. Now, what do you notice about the triangles marked in blue? How can we describe them? Yes, we can describe them in terms of triangle ECF plus triangle BMC. That is how we can express the area of the blue triangles. And we have just established that this area is 1/2 the area of the whole figure. Now that we have found this relationship, how do we solve for triangle BMC's area? The first step, of course, is we need to figure out the area of the whole square. So, how do we find this area? We would just take the side length of 12 times 12. So, we find that the area of this whole figure, the square, is 144 centimeters squared. Now, what would the next step be? The next thing we can calculate is the area of triangles ECF and BMC. That is half the area of the whole figure. And how do we calculate that? Simply just take 144 divided by 2 to get an area of 72 centimeters squared. Now, what is the next step to finding our area of triangle BMC? That's right, we just take this half of whole figure area and subtract by the area of triangle ECF. So that's 72 minus 48, and we get triangle BMC's area of 24 centimeters squared. And that is our final answer. Now that we have solved this question, let's summarize everything we have learned so far. So, in this question, remember, at the start, we were not able to solve directly for the triangle's area. So, what other solution did we have? That's right, we are trying to find a relationship. And in this case, we are trying to find a relationship between two triangles in a rectangle. And of course, in this question, it is a square, which is a special case of a rectangle. And which model did we use to consider this relationship? That's right, we considered the half model. Thank you for watching today. If you'd like to contact me, you can scan the QR code on the left. And if you'd like to join our Primary 4 study group, you can scan the QR code on the right. Thank you again for watching. Happy studying and see you in the next video.